Cities are often referred to as mankind's greatest invention. We are drawn to cities. In fact, by 2020, 70% of global population will live in cities. This, however, comes at a drawback. Already today, we have 50% of global primary energy consumed in urban settings. Buildings, infrastructure, energy systems impact the lives of millions of people. One example we see in the media these days is the urban heat island effect. Heat that is emitted and stored in the city. And it increases the death rates in many cities all over the globe. Despite the implications on a small and large scale, we know surprisingly little about the interactions of our energy system supply and architectural design and urban design. And this is the reason because it's quite complex. We have the linkages between energy technologies and spatial development. We have multiple stakeholders working with different agendas on different timescales. All over the entire development of the cities on a very long timeline, which raises uncertainty. If we look back, it's interesting. At the time when we only had renewables, a city was always automatically linked to energy. Cities could only dwell and develop with access to renewable energy. For example, Zurich in this example. And we can see the imprint of energy logistics in our cities today. So after 200 years of fossil fuels, we face the problem of reintroducing renewable energy into the city. And with it, it comes all the spatial constraints, the spatial considerations. Building morphology, placement of buildings, surfaces, network lengths, all these aspects impact both urban design development as well as renewable energy systems. We have to learn more about the interactions of those two different domains. The building itself is quite limited and the city is too complex. This is why we think in districts. District energy systems have proven to be very efficient of harnessing renewable energies, balancing consumers and producers, and at the end, reducing heat loads into the city as well as noise implications. In order to design these district-scale systems in an integrated way, of course, we start with looking for data. Spatial data, georeferential data, for example, as in this case, that is linked to ages, construction types, and other information on buildings is the base foundation. The geospatial reference is truly important. The second type of data that we need is operational data from buildings. The increase of building management systems and monitoring systems allows us to have access to a lot of data that explains and shows us how systems and buildings actually work. This operational data allows us to look at loads and demands and dynamics of energy supply in buildings that we can upscale then on the entire district level. The third category of data is occupational data. How do we humans move in cities? This is an example of the National Science Experiment in Singapore, where 40,000 students have been equipped with mobile sensing devices collecting data for weeks. We can use this data using machine learning techniques to infer, for example, the usage of air conditioning in buildings, which is a very, very relevant information for us. If we have this data, we can create specific maps. We can see patterns of energy demand and supply that is individual for each district as well as for each city. We can look for synergies between spatial use and energy systems behind that. As part of our work, we've fused these databases into an open source modeling environment, which we call the City Energy Analyst. With different universities, we're developing a tool that allows us to model the morphology of cities, model the energy systems, and then be able to simulate and optimize using optimization schemes to find perfectly balanced solutions that acknowledge urban design parameters as well as energy parameters. This is an example. This is Tanjong Pagar in Singapore, where the question is, what is the share of renewable energies we can bring into in context of functional distributions, so usages in space, and urban density. How dense can we build the city to keep a certain share of renewables? This allows us to build scenarios. Each scenario represents a trajectory of potential development on both the energy systems as well as on the urban design. Each scenario itself is not valid. It's just a primer for discussion with stakeholders, which should be the directions we should take, what are the relevant parameters we should look after. And of course, it's great to deal with tool sets, but we also have to change mindsets. It's very important to educate the next generation of planners and decision makers with this integrated and holistic thinking about those systems and expose them to the tools. This is an example of our course in Zurich, where we work with architects and engineering students on real cases of integrated design. So concluding, we can say we have to reintroduce renewables at a large scale into cities. We have to look at the implications of space versus energy systems. We have to harness the data that is increasingly available to build tool sets that at the end are available for today's decision makers and planners and future decision makers and planners in order to build livable and zero carbon cities. Thank you very much.
Great.